So let's get started. Understanding version control, Git and GitHub is crucial for any developer or any team working on a software project. So far, we have been building our websites just by setting up folders on our computer, opening them up in VS Code. But to professionally build websites, you will need to track the code in a version control system. So these tools allow you to track changes. They allow you to collaborate with others because you're typically not going to be the only one working on a web application or website. And they also allow you to deploy your applications easily and efficiently to the cloud. And by mastering these skills, you can streamline your development workflow. So today we are going to learn what professional web developers use when they're working on these projects. So in particular, we are looking at these topics. We will talk about using GitHub repositories to store and share your project source code. We will talk about using GitHub Codespaces, which is an online code execution and online development platform in conjunction with a browser-based VS Code for web development. We will talk about developing and previewing changes to a website using GitHub Codespaces. We will talk about creating Git commits and pushing changes back to a GitHub repository. Then we talk about deploying a website to the cloud directly from GitHub using the Vercel cloud platform. And we'll try to understand the GitHub collaboration workflow, which involves branches and pull requests. And finally, if we have the time, we will also touch on installing and using Git locally on your computer and connecting it with GitHub. Now, the best way to learn these skills is to follow along step by step and type out all the code yourself. Git can often be confusing at first, so I want to start with that disclaimer because there are so many different terms that you will hear: git pull, merge, commit, etc. But it starts to feel natural with a lot of practice, and you will see us repeating the same flows over and over for the rest of this course and the rest of the program. So by the end, you will become proficient in Git, whether you like it or not. Now, of course, this tutorial assumes some prior knowledge of HTML and CSS. So if you haven't completed the previous lessons, please go ahead and complete them first. So we will explore these topics by attempting to work on a specific problem statement. We want to improve the development workflow for the Jovian Careers website. So in our previous tutorials, we've built this Careers website, which has a navigation bar, which has this banner, which has some information about Jovian, an image, which has a table showing the job opportunities at Jovian, and it has a form where anybody who is interested in applying for a job at Jovian can submit their application. And finally, it has a footer at the bottom as well. And we built this by setting up a folder on our computer locally and then uploading a zip file to static.app. And that is how we have this deployed version. So what we want to do is set up a GitHub repository to host the source code and facilitate collaborative development. We also want to deploy the website directly from GitHub to the cloud using the Vercel cloud platform. And we also want to add some appropriate meta tags, which we'll talk about today, to ensure that when you share this website with somebody, let's say on a social platform or as a link on a messaging platform, then the page previews properly. So all of that is something that we'll try and cover today. So here is where you can find the code for this tutorial. We are going to start with the starter code, which contains all the code for this website that you're already looking at, which we have developed so far till in the previous tutorials. So let me open up the starter code. This is going to be a zip file. I'm just going to save it here on my desktop. And once it's downloaded, I can then, you can see here it's downloaded on my computer. I can then just decompress it. So now I have this folder. So in this folder, I have the index.html file. I have a couple of other styles file. I have a couple of images. And this index.html file contains the actual application page, the Jovian Careers page. Okay. But of course, we are not going to do this development locally. We are going to do this development now using GitHub. Now, I'm sure if you are pursuing web development, if you have done any programming, you must have heard about GitHub. And you must have also heard the terms Git and version control. So first, I just want to demystify these terms before we start using them. Now, Git is a popular version control system which enables developers to track changes to their code base and collaborate with others. And GitHub is a web-based platform that provides hosting for Git repositories and tools for collaboration. Okay, so let's break down each of these terms one by one. What do we mean by version control? Version control is any system that tracks changes made to a file or a set of files or a project. So it enables developers to keep track of different versions. Instead of you having to create multiple copies saying V1, V2, etc., you can just put everything into a version control system systematically. It also enables developers to collaborate with others so that you can have one common version and two people can build off it, then you can bring those changes back. And sometimes when required, it also allows developers to revert to previous versions of their code if needed. And it enables developers to work on different versions of their code simultaneously. So as a developer, sometimes you work on multiple features at a time. And again, you need a version control system for doing that. So there are many version control systems. There's one called SVN that was very popular early on in the 90s. There is, of course, Git, which we'll talk about today. And there is something called Mercurial. So version control system is any system that allows developers to track various versions, track changes of files or projects. Now, you can learn about the various version control systems and the differences between them. I have linked to a site, but we are going to focus on a specific kind of version control system called Git. Now, the key concepts behind Git are that you have typically a remote server. So typically this remote server could be something that you have set up, your company has set up, or it could be an online platform like GitHub. So you have a remote server where the master version or where the main version of your code is stored. And this code is called a repository. So your code is stored in something called a repository along with all its previous versions. And then whenever you as a developer want to work on this code, you first have to pull it onto some computer. So it could be a local computer, it could be another cloud computer. And then you make some changes on your computer, and then you send the changes back to this remote server. And you're not just the only developer on this. There can be other developers who can be doing the same thing. Okay, so Git is this particular kind of version control system where you have now often this central server which stores the repository of code, and then you take a copy of the code, make some changes, and push your changes back to the central server, and that is how people collaborate. Okay. So that is how Git works. And here are a few concepts in Git that we will try and cover today. So the first thing in Git is that it uses something called a branching system that allows developers to work on different versions of their code simultaneously without affecting the main code base. Okay. The second thing is that developers can make changes to their local copy, and then they can push those changes to a central repository. Next, suppose two developers are making changes to the same file or the same set of files, then Git also allows developers to merge their changes, the changes made by different team members, and resolve any conflicts in case both team members are making changes to the same file. Finally, Git also has the ability to track changes made to individual lines of code. So when you're trying to merge some of your changes back to the cloud repository, you can check what individual lines of code have changed. And you can also roll back to previous versions of the code. Okay, so it is one of the more sophisticated and one of the most widely used version control systems. And don't worry if these concepts don't make sense right now. We are going to cover all of this in much more detail over the course of today's tutorial. Okay. Next, what is GitHub? So we talked about version control, any system that can be used for tracking changes across files and folders. Git is a particular kind of version control system where there's a central repository, and then you can take copies, make changes, and push them back using branches. Then we have something called GitHub. Now, remember in Git, there is this central repository that can be a repository that you have set up, your company has set up, or you can use one of existing central repositories. And GitHub is the world's largest central repository for Git-based projects. Okay, so GitHub is a web-based platform that provides hosting for Git repositories, and it provides a range of collaboration tools on top of that hosting for developers. Other similar platforms are GitLab and Bitbucket. So you can use any of these. All of them have free plans, but GitHub is the most popular one. It has tens of millions of people using it. So you should probably start with GitHub. Now, on top of Git, GitHub offers several additional features. The first thing it gives you is a web-based interface for managing Git repositories, making it easy to view and manage code. It also offers a wide range of collaboration tools on top of Git, things like pull requests, code reviews, and team management features. Again, we'll touch on these. And finally, GitHub also provides hosting for open source projects. So most software that you use on the internet is built using open source projects, and these open source projects are typically hosted on GitHub. So GitHub is a great place for you to discover open source projects and even contribute to open source projects. And it has a vast community of developers where you can interact with others and you can interact with developers of open source projects and make your own contributions. Finally, GitHub also provides integrations with other tools, specifically around deployment, project management, etc., to make it a complete software development workflow. Okay, so GitHub is a hosting platform for Git, and it offers a lot of additional features on top of Git. Okay, so I hope that clarifies the difference between Git version control and GitHub. They are like layers. Version control is a basic kind of a system. Git is a specific kind of version control system. And GitHub is a hosting platform for Git repositories with some additional features. So let's start by first creating a repository for our project. So projects on GitHub are known as repositories. So we'll go ahead and create a repository. So the first thing you might need to do is go to github.com and sign up if you're not signed up already. In my case, I have already signed up. So I'm simply going to sign in. So I'm just going to click sign in. And that is going to sign me in to GitHub. All right, so once you sign in, this is what your dashboard looks like. And on your dashboard, the first thing you want to do, at least when you've created your account for the first time, is to click the new button to create a new repository or a new project. So let's create a new repository. We are going to call it Jovian Careers Site Live because I'm doing this live. And let's add a description for this repository. So a website to show job applications at Jovian or job openings at Jovian and accept applications. Next, you can choose whether to make this repository public, which is open source for the rest of the world to see and build upon, or you can make it private. Now you can make it public and people can see the code, but they cannot make changes to your repository. You still control who can make changes. But if you make it private, only you will be able to see it. And if you add collaborators, only they will be able to see it. And you can also choose which of those collaborators can actually make changes to the repository. So for now, I'm just going to make it public so that you can actually see the code by the end of this lesson yourself. Next, you have a few initialization steps. So if you are creating a repository on GitHub and you plan to develop from this repository, then you should initialize it with a README file and some of these other things. On the other hand, if you already have a repository on your computer, you just want to upload it to GitHub, then you can skip these initialization steps. Okay. In my case, I'm just going to select this initialization step, add a README file. What that's going to do is just create a file called readme.md, wherein I can put in some documentation about my project. So I'm going to keep that. And then there is something called a git ignore file that gets added. So often when you are creating a Git repository, there are certain temporary files that can get created as you're executing your code. And you may not want to put those temporary files or compiled files into your Git repository. So that's where a git ignore file comes in. Don't worry about this. We'll touch on this later. But for now, because we are going to create a JavaScript, an HTML and CSS project, so the git ignore template that you can select is Node. So Node simply stands for Node.js, which is a tool used to run JavaScript and HTML and CSS based projects locally on people's computers. So you can just select the git ignore template Node. And if it doesn't make sense, don't worry. It's not important right now. And finally, you can also select a license. So when you put up any code on the internet, specifically on GitHub, you can inform people what they're allowed to do with the code. Are they allowed to build on top of the code? Are they allowed to use the code for academic purposes? Are they allowed to use the code for commercial purposes? You can specify all of that. And one of the most common licenses is the MIT license, which basically allows the user of your code to do anything they want to do with the code whatsoever without any warranties. Okay, so that is just the common template. So what you'll often do when you create a new GitHub project is you'll add a README file. You will select a git ignore template. For JavaScript or HTML CSS projects, this is typically Node. But let's say if you were doing a Python or a data science project, you could select Python and so on. And you will also select a license. In many cases, MIT license should suffice. And you can learn more about all of these, the README file, the git ignore, and the license by checking out these links. Okay. Now, finally, as I said, Git has a concept of branches. So the first thing you have to do is when a GitHub repository gets created, it has a default branch. And the default branch is often called the main branch. Okay, the main branch is where the main version of your code lives, but you can then create multiple branches as you're working on specific features, and then you can bring those code from those branches back into the main branch. Now, for now, we will go ahead with main as the default branch, but know that sometimes in some older repositories, the default branch name was called master, M-A-S-T-E-R, but the new convention is to call the default branch main. So that's what we'll go ahead with. Okay. So let's hit create repository, and now our GitHub repository is created. Perfect. So you can see now you have this fairly complicated looking interface. You have a navbar here, then you have a bunch of buttons, then you have a bunch of tabs, and you have again some options, etc. So I know it looks complicated, but we will touch on almost all of these tabs over the course of the next several lessons and over the course of the program. But for now, what I want you to pay attention to is this area. So here is your username. You will see a username here, and next to your username, you will see the name of the project. So the name of the project is Jovian Careers Site Live. Typically, these are all lowercase, and typically these are all separated by hyphens. And then in the code tab, you're going to see that in the main branch, which is the only branch we have right now, we have 3 files. So our repository has been initialized. You can see that there's an initial commit. We'll talk about commits as well. 1 minute ago with 3 files. One is a README file, one is a license file, one is a git ignore file. And you can open up this license file and you can see what it contains. Similarly, you can open up this git ignore file and you can see what it contains. And you can open up this readme.md file and you can see what it contains. So again, this is all created using Markdown, which is a fancy way of writing text. So there are 3 files in our repository. And at the moment, our GitHub project or repository has been created. So we can already go ahead and share this with other people. Let's say we want to share our code with other people. We can take this link and share it with them. But of course, we don't have any code here right now. So the next thing we're going to do is actually import our code into this repository. Now, there are 2 things we can do. We can actually start writing some code, or we can start importing some existing code that we already have. In both cases, we need to open up this Git repository in a code editor. Now, you can download this Git repository to your computer and then open it up in VS Code or any other code editor. Or you can also use some online platforms for developing on this GitHub repository. Specifically, GitHub provides something called GitHub Codespaces, which you can think of as your own personal computer attached to this GitHub project or repository, but living on the cloud. All right. So GitHub Codespaces is a cloud-based development environment that allows you to write, test, and debug your code directly in the browser. So it allows you to quickly set up a development environment without needing to install any software locally. It provides a consistent development environment across different machines because you're writing all your code in the browser, and the browser is connected to some machine on the cloud where all of the dependencies are already installed. It also makes it very easy to collaborate on code with other developers because you can have real-time shared code spaces. So if you're writing code within a code space, you can create a shareable link, invite somebody else to come and collaborate with you live. And it lets you work from anywhere, so you don't have to work from a particular computer. You can just open up your GitHub repository and launch a GitHub Codespace online and start typing code into it. Okay, so you can think of it as a personal computer on the cloud that you can access from anywhere. And you can check out GitHub's documentation for setting up code spaces. But starting a code space is really simple. What you do is you go to your repository folder, and or you go to your repository on GitHub and you click this code button here. and you have two options. You have local and you have Codespaces. And here you can click create Codespace on main. So what this is going to do is this is going to set up a computer for you on the cloud, and it is going to associate that computer with this GitHub repository. So you can see here, if I zoom in a little bit, it has set up this cloud-based computer for me, and it has opened up Visual Studio Code on that computer, and it has given me a browser-based interface to connect with Visual Studio Code on that computer. So there's a lot going on here. So instead of opening Visual Studio Code on our own computer, we have opened up Visual Studio Code on a GitHub Codespace, which is a computer running somewhere on the cloud. All right. So this is what it looks like. Remember, we on our GitHub repository, we had these three files, gitignore, license, and readme.md. So if you come here, now you can see that we have the same GitHub repository now open for editing in this Codespace, accessible via this browser-based Visual Studio Code interface. Okay, so within the browser we have Visual Studio Code, and I can open gitignore and I can make some changes here. I can open this license file and I can make some changes here, and similarly I can open this readme file and I can make some changes here. Okay, but what we want is to actually put in the code that we already have from our previous tutorial, which is the index.html, styles.css, and a couple of other files. So here's what we'll do. As you work on more complex projects, it is going to it'll be a good idea for you to separate some of these configuration related files like gitignore, license, etc. with your actual source code. So what I'm going to do is create a folder here. So I'm going to right click and select new folder, and I'm going to create a new folder called src. So now I have created a new folder called src, and into this folder now I can add an index.html file. So I can say index.html. And now I can maybe put in some HTML code here, and maybe I can start writing things and so on. But I already have a bunch of these files, so I can just upload these files. So let me delete this file once. Let me just delete this file index.html, and let me upload these files from my computer onto this remote machine. So I'm going to say upload. I right clicked on src and I'm clicking upload. And now I'm going to open up the folder my second web page. And now I'm going to select the files that I want to upload. So I want index.html, I want styles.css, I want theme.jpg and banner.jpg, and I'm going to click open. All right, so now all the files from my computer have been taken and uploaded into this cloud Codespace, this cloud machine, which I'm accessing using VS Code from the browser. Okay, now I can actually go ahead and delete this folder entirely. I don't need it. But all of this code is still going to be here for me. Okay, so remember we had this Jovian career site that we built the last time, and this was built using this index.html file. So let us look at this index.html file. It has a head section where it has a title and it has a bunch of fonts that are included. Then it has a body section which contains a nav bar, which contains a banner, and it contains this heading. So we have a nav bar, banner, heading. Then we have this about description section where we have some information about Jovian, and we have links to the two programs. And then we have this team image over here. And then we have a list of job opportunities, which is a table. So that is the job opportunities table that you can see here. And finally, below this, we have a form. The form contains a bunch of form inputs. And then there is a footer below the form, which is what you see here as well. So there is a form. And then there is a footer below the form right at the bottom. Now, of course, these HTML elements are styled using CSS. So we've set a base font size on the HTML, and then we've set some body fonts, and we've set some header fonts as well. We've also set specific sizes for the headers. We've set specific colors for headers and for body. We've also set a bunch of other colors, and then we've set a bunch of other CSS styles to make our page look as we want it to look. And we have set some styles for the table, we have set some styles for the form, and we have set some styles for the footer and for the button. Okay, so that is what our code looks like right now. So for now, I'm going to close this deployed website. And now let's try and figure out how can we actually preview this. Okay, so now we have some code already on this Codespace, but this code is no longer on our computer. This is on the remote machine. So there's no place where I can double click and open it in a browser and preview it. So there is an extension or a plugin that we can install into VS Code for previewing these files. All right. So this is one of the nice things about VS Code, that depending on which language or which kind of project you are building, you can install some plugins to ease your development. So I'm going to go click on extensions, and then here I am going to search for live server. Okay. So just search for live server, LIVESERVER. It is created by this person called Ritvik Dey, and you'll know because it has 32 million downloads. So that is how many people actually use VS Code and also use this extension. And I'm going to click install in Codespace, and that is going to install this plugin into my Codespace. Now, once this plugin is installed into the Codespace, I can close this extension tab. And by the way, the extension menu is here on the left. So in the sidebar, it is this fourth or fifth option. Yeah, it's the fifth option in the sidebar. So that's how you come to extensions. And now that I've installed this extension, I can come back here onto my file explorer. And now I can see here that on my index.html file, if you see at the bottom here, I have this go live button right at the bottom here. So this is a new button that has been added by the live server. Or I can also just right click on index.html and I can say open with live server. Both of these are going to do the same thing. So I'm just going to click the go live button. What that does now is it is going to now set up our code space to expose this file to the browser at a separate URL like this. Okay. So now let me put this on the left, and let me put this, on the left and right. And let's close these. Let us also close the sidebar. Now you can see that here I have my code space running on the cloud. So my VS Code running in the browser, and I have a live preview of my code running here, open using the live server on the right. Okay. Now here is one nice thing about the live server. Let's say I want to go back and I want to change here. I want to change about Jovian to welcome to Jovian. And I just hit save. That goes ahead and that automatically refreshes the page. So the live server makes it slightly nicer to develop. And I can also go and do this with the styles.css file. I can say, let's say, change the default font size from 16 pixels to 18 pixels. And I can save it. And you can see that now the styles file has been updated. And now we have, let's make it 20 pixels maybe. And now you can see that these things are a lot bigger. Okay. So this is one of the nice things about the live server. All right. So, oops, I think I pasted something. Yeah. So this is one of the nice things about the live server. You can go in, you can make some changes here. So you can say, maybe I want to get rid of the word highly, and I just save, and that changes this automatically. Okay. So that is how you view the code that you are building, that you're writing on, especially when you're building a simple HTML and CSS page. Later on, when we look at web frameworks and things like React, etc., then we'll touch on other ways to look at previews. But on GitHub Codespaces, this is how you look at a preview of your code. Okay. So just to quickly recap, to start a code space, you go to the GitHub repository, you click on the code button, and you select open with Codespaces. You can create a code space on your main branch if required. And if you ever need to, you get 2 free code spaces. So if you ever need to delete previous code spaces, just go to github.com/codespaces. And over here, you can go into your specific code spaces repository wise, and you can go ahead and delete them in case you have a new repository that you want to develop using a code space. Okay. And then you can select a code space configuration. Typically, the basic configuration should be good enough. Then the code space gets created. It takes 10-15 seconds. And then you can just open up Visual Studio Code in the browser, or you can actually also connect your local Visual Studio Code to the code space. We're not going to go into that today, but browser-based development is good enough for most projects. And then you can continue working on your Codespaces project. All right. Now, in terms of how you do actual development, well, what you do is you can, one thing that we recommend is that now anytime you're putting your actual web code, you should create an SRC folder to separate it out from the README, git ignore, etc., just to keep things clean. And now you can add files like index.html, styles.css within the SRC folder, and you can add code within them. And you can also upload existing files or images by simply right-clicking. So you can open up the sidebar, right-click anywhere, click upload file, and upload a bunch of files. And if you want to preview HTML files within Codespaces, you just use the live server extension. And this extension allows you to see your web pages as you develop them. And for that, you just go into the extensions section here in the sidebar and you search for live server, install it, and then you go back and just click go live. And you can also shut it down. There's a button right at the bottom to shut things down as well. And once you do that, you will be able to see a live preview and you can make changes. So for example, if I change welcome to Jovian back to about Jovian, that is going to quickly change over here as well. Now, this is all well and good. I'm making all these changes. But if I go back to this repository, you will see here that it still does not contain the code that I have actually added. So I've added a bunch of files, but they don't seem to be here in the GitHub repository. Well, remember this setup. So we created a repository on GitHub, and then we pushed that code, or we pulled that code into a code space, which is essentially a remote computer on the cloud. And now we've made some changes into our code space machine using VS Code. Now we need to push these changes back to GitHub to actually save them back to the remote repository. So that's what we're going to look at next. Okay. So how do we do that? Well, it's a 3-step process. And we're going to first stage our changes. Next, we are going to commit our changes. And finally, we are going to push our changes. And this is where some of the GitHub terminology will start kicking in. You might wonder, why do we have 3-step process? Why can't I just hit save? Well, this is just how Git was designed to handle a bunch of different use cases. And that is what we are stuck with, unfortunately. But once you do it enough, you start to get used to it. And I'll show you some easy ways of doing this without having to type or remember a lot of things. Okay. So here is how it works. The first thing we need to do is we need to open up a terminal. So Git added score is a command line tool. So you need to actually type out some commands on a terminal or a command line. So we need to open up a terminal to run some of these commands. Now, of course, we have our code space somewhere on the cloud here. So we can't open up a terminal on our computer. We need to open up a terminal on this remote machine, which is in the code space. Fortunately, VS Code provides an inbuilt terminal. So you can just click on these options here and you can say view and you can select terminal. So view terminal. And now that is going to open up this terminal window. Okay. And what is a terminal? A terminal is simply a place where you can issue commands. You can write commands and those commands will get executed on the computer. So before we had graphical user interfaces, operating systems were just terminal-based, text-based platforms where you could issue commands. And even today, most developers use these command line or these terminal commands to run a lot of their code and to interact with Git, for example. Okay. All right. So now we've opened up this terminal. So it has this. You can see that this terminal, it has a bunch of information already. It tells you who is the current user. So the current user is Sydney Jovian. That is the name of our GitHub user. It has the current directory or the current folder on the code space where we are currently at. And it also tells us the branch that we are currently at. So it's an informative prompt. And now here we can start typing our terminal commands. So the first command that we need to do or we need to type is called git add. Okay. So the first thing we need to do is, or actually even before we do git add, we can just type git status to see what status our repository is in. Are there any new changes that we have made since we have checked out the repository from GitHub? So if I type git status, you can see here that it says that you are on the branch main, and then there are a few untracked files. And there are a few untracked files, and they are the files in this folder called SRC. So the entire SRC folder is untracked. By untracked, we mean that Git has no idea about these files. It has never seen these files before. So the first thing we need to do is we need to stage these files. So we take the files from our working directory and we stage them, which means we tell Git that, okay, these are some files that I'm interested in potentially putting back on GitHub. So I'm going to stage them by saying, first of all, I'll just reset it. So anytime you want to reset the terminal, just type reset. And I'm going to just stage this by typing git add src and src / what are all the files that I want to stage. I want to stage index.html, banner.jpg, styles.css and theme.jpg. Well, I'm just going to type git add src. and that is going to add all the files present within the src folder into the staging area. Okay, so now if I type git status again, this time you're going to say that it's not saying that there are any untracked files. So there are no more untracked files. There are some files which are ready to be committed. Okay, so now in my staging area, which is nothing is yet put into the Git repository yet, we now have 4 new files. Okay, great. So now that we have staged these files, so from working directory, we've staged these files. The next step is to actually record a new version of this entire repository by performing a commit. So here is what we do after adding a git add. So I've reset things again. Now I type git commit, and then I say -m, and then I provide a message. So adding the HTML and CSS files. Now I have to provide this message within quotations. So you can see here git commit. If I need to zoom in a little bit, likely this is fine. Git commit -m, and then I provide a message, and the message is within quotes. So now I'm recording a new version of my code by creating a commit, and I'm giving it the message adding HTML and CSS files, and I press enter. Okay, and now it says that okay, now it has actually inserted 4 files into my repository. So now you can see that now we have the create mode. Now we have created a file called src banner.jpg, index, styles, and team.jpg. Where are these files created? They were already present on our code space. Well, they have been now created and saved within our repository, formally saved. Okay. And now if I reset once again and I say git log, now git log is used to view a history of all the commits. And now you can see that there are 2 commits, or 2 times that I've recorded a version. A commit is simply a version of the code. So there was this initial commit that was done at such and such time by such and such author. The initial commit was done, and then I have done a second commit, and in the second commit I have added this HTML and CSS files. So that is also something you can see. Okay, you can in fact do git log -- stat, and that is going to tell you what is the change in each commit. So here you can see that in the initial commit, we added a git ignore license and readme.md file. So I'm just using the arrow key to go up and down. And in the new commit, adding the HTML and CSS files, I have src banner, index, styles, and these are the number of lines in each of these. Okay. Now, often when you run some git commands, you will have to do this scrolling using your cursor, up and down cursor. So here's a quick trick to exit this. Just type Q to exit this. Okay. Anytime you're stuck in some git command output, just press Q and you should be able to exit. All right. So let me reset that again and let us check git status. So now it says we are on the branch main and there is nothing to commit. Our working tree is clean, which means we have no untracked files. We have no tracked files with changes to be committed. So that's fine. So we have taken our working directory changes. We have first staged them. And then after staging, we have committed these files. Let's see if these have shown up on GitHub yet. No, these do not seem to have shown up on GitHub yet. We still have a git ignore. We still have a license and a readme.md. So once again, coming back to this, what we are doing here is so far, we are still just recording new versions of our code on this code space machine. We need to push these changes back to GitHub. That is where the git push command comes into picture. And you can see here, there is actually a hint here saying that your branch, so our main branch, the main branch on our code space is 1 commit ahead of origin main. Origin typically refers to the remote server, the whatever repository remote server from where you've actually pulled this code. So we are ahead of our origin, or we are ahead of the remote server by 1 commit. So we need to push our commits. So here's how we push it. Let me reset that again. Let's just type git push, and then we provide origin. So we want to push to origin, which is sort of the remote server, and we want to push the main branch. So git push origin main, and I press enter. And now you can see that we are packaging up all of these new changes that have been recorded in the new commit, and we are pushing this to the cloud server. Okay. So now what happens is we have made some commits here. We've pushed them back to GitHub, and now the next time we run a code space or somebody else runs a code space on the same repository, a collaborator maybe, they are going to pull the latest changes. All right. So that is how you actually push your changes back to GitHub. So once again, I reload the page and now you can see now finally we have this src folder over here. And in this src folder, we have this index.html file. So that's great. That's exactly what we expect. And we have the styles.css file and so on. Okay. So that is one way in which you push your changes back to GitHub. Sorry about that. So that is one way in which you push your changes back to GitHub. So just to recap, you open up the inbuilt command line terminal using the browser-based VS Code window. Then you review the changes that you've made using git status and git diff commands. I'll talk about git diff in a second. Then you can stage the changes that you have made by typing git add a specific file name, or you can just type git add dot, and that is going to add all the files that have been modified or added. Then you can commit your changes, the changes that you staged by typing git commit -m followed by a commit message inside quotations. Commit messages are very important because they give you a short description of the change you're making. And finally, you can verify that the change was made using git log. And you can push your changes to GitHub by simply typing git push origin main, or in the case of the main branch, you can just type git push. So this is typically the workflow you have. You add some files, you commit them, and then you push them. And if there are new changes that are made on GitHub, you pull them back onto your computer. Okay. So if I run git pull origin master, for example, you will see that, git pull origin main. So if I run git pull origin main, for example, you will see that I'm already all up to date. Now, what is origin? Origin simply refers to that remote server from where you have pulled the repository originally. So it is the origin of your code. It is the original place from where you've pulled your code. Okay. So, and again, this is where Git gets confusing. You have origin, remote, this and that. But that's what origin means. Okay, now one other thing I want to tell you is, let's say we make a change here. So we say about, instead of about Jovian, let me change this back to welcome to Jovian. So the live server should also reload to show welcome to Jovian. And now just to quickly recap the flow, I can check git status. And you can see here that now we have modified the file src/index.html. Okay. So now it is telling me that something has been modified. Now, whenever a file is modified, you can actually see what changes have been made by typing git diff. So when you type git diff, GitHub is going to show you, in red, it is going to show you which files have been removed, which lines have been removed. And in green, it is going to show you which lines have been added. And everything else in black is simply the code around that line. So it is telling us that in index.html, we have removed one line and we have added one line. Okay. And that is how GitHub tracks, or Git tracks changes. It tracks deletions from a file and it tracks additions from a file. Okay. And once again, we can now do git add dot, we can then commit, we can then push, but there's another way to do it directly within VS Code. So you can click on this third button here called source control in the sidebar. And what this tells you is, this shows you under this changes section, it shows you all the untracked or modified files. So it seems like there is this index.html file that seems to have been modified. And there's also this settings.json file. Well, maybe I don't need this file, so I'll just delete this file for now. Let me just come back here and let me just delete this entire folder. Maybe it got added somehow. I don't need it right now. But anyway, coming back here. So now I have this index.html file, and in this index.html file, if I click on it from the Git sidebar, I will be able to see the changes that have been made. So you can see that in index.html, it is showing me a comparison between the original version, which contains about Jovian, to the new version, which contains welcome to Jovian. So we have removed about and we have added the welcome to, or you could also think of it as we've removed this entire line and added this entire line. Okay. If we made some more changes, for example, in index.html, let's also add the word most highly reputed. And let us come back here and let us check. You can now see that apart from this one change, we also have the second change over here. So you don't actually need to run the git diff command. You can simply come into the into the Git sidebar and you can check the changes. Let's maybe go back and also make a change into styles.css. Let me change the body font color. Instead of 444, let me change it to 404040. A slight change. And once again, I can go here into the Git sidebar and I can see that there is a change made in styles.css and there is a change made in index.html. Now I can go ahead and stage these changes one by one. So I can review the changes in each of the files by looking at the diff or the differences. And then I can stage these. I can click plus here and I can click plus here. So remember the flow. We first have to add the files to stage them. So I can click plus and styles has been staged, or I can unstage it like that. But let me just stage this and let me stage this. Or I can also stage them both together by using this single plus button. Now you can see that we have a couple of stage changes and no other changes, no unstaged changes. So internally, VS Code is simply running these Git commands for us so that we don't have to run them. But you should be still familiar with Git commands in case you don't have the sidebar or you're not using VS Code. Okay, so now that the changes are staged, we can type a message here. So let's say updated index and styles. And now we can click commit. Okay, now the changes have been committed. So we've added the files and now we've committed the files. But now we still have to send these back to GitHub. So now we can click sync changes and now it says this will pull and push commits from and to origin main. And I'm just going to say okay. And now my changes are going to be sent up completely. Okay. So that is the other way to send updates to GitHub. Make some changes, come here, then stage those changes and then commit those changes with a message and finally press the sync button and that is going to push the changes up to GitHub. All right. So two ways to do it. I generally prefer doing it from the terminal just so that I can keep getting some practice. So I prefer doing it from here, from the terminal, but feel free to use the user interface as well. Both are equally good enough. Both do exactly the same thing. Okay. So as an exercise, I encourage you to look up the documentation or look up some tutorials to understand these Git commands. Git status, which tells you what untracked files you have or what are the files with some changes. Git diff, which shows you what are the exact changes in each of the files. Git add, which can be used to stage your files. So go from the working directory to the staging area and you can add individual files or you can add all files or you can add a folder at once. Then git commit, which is used to actually record a new version. Then git log, which is to see the history of commits that you have. And finally git push, to push these changes to the remote server or origin server. And you also have git pull, in which case, which is used to pull the changes from the origin server in case somebody else has pushed some new changes. Okay. Now all of these commands also support some options. So you can check out what their options online and you can also use git help. But the thing with Git is you have to practice, you have to try these out a few times, you have to get stuck a few times and only then you start to feel comfortable. But we've already covered 6 Git terms and there are a lot more that are going to come. But at this point, I want to switch gears and talk a little bit about cloud deployment. So now we have our Jovian career site live. You can see here that we can see its history, that 3 commits have been made so far on GitHub. We can see that there's an SRC folder and that was recently updated with the index and styles that we committed directly from VS Code. And there are some other files from the initial commit. How do we take this and how do we easily deploy it to the cloud? We're going to do that using this platform called Vercel. Vercel is a cloud platform that makes it really easy to deploy websites and applications, and it offers a seamless integration with GitHub and other version control systems, allowing developers to deploy their projects almost instantly without any additional coding or any additional work. So here is what we are going to do. We are going to sign up on vercel.com. So let me just sign up. In case you're not signed up already, you'll need to sign up. I am already signed up and signed in, so I'm good to go. Then you will be taken to the Vercel dashboard as soon as you sign up. Let me zoom in here. And you can add a new project. So I'm going to select new project. And when I select new project, it is going to ask me access for my GitHub repositories. So when you're signing up, try to sign up with GitHub so that you can give permission to sign up using GitHub directly. But second, when you actually try to create a project, Vercel is going to need access to your GitHub repository so that it can pull out the code and it can then deploy them to the cloud, not just public repositories, but also private repositories. So you can either give access to all repositories, or you can give access only to select repositories, and you can select which repositories you want to give access to. In my case, I'm going to give access to all repositories, and it is going to have access to read and write, because it is also going to write some things into your pull request, which we'll talk about later. But in general, yeah, you need to give Vercel full access to your code so that it can pick it up, even private code, and deploy it to the cloud. Okay, now let's click install. So that is going to install the Vercel GitHub application essentially. And now at this point, you will see this new project box. And in this new project box, you can select which GitHub account to use in case you've connected multiple GitHub accounts. And from that GitHub account, you can select which site you want to actually deploy. So my repository is called Jovian Career Site Live. So I'm just going to click import Jovian Career Site Live. And now I have to configure the project, because Vercel has configurations for all kinds of various different projects. So you can see here that it has a bunch of different pre-configured frameworks. And first you can set a project name. I'm just going to keep the project name on Vercel the same as the project name on GitHub. No change here. So Jovian Career Site Live. The framework preset, I'm going to select other, because I'm not actually using a framework. I'm just using simple HTML and CSS files. Then I need to select the root directory which needs to be deployed. So remember, we created this src directory. We don't want to deploy our gitignore file and license and readme.md. That's not something we want to put on the website itself. That's something that we want to just put on GitHub. So let's select the src folder or the src directory as a root directory. So I'm going to click edit here, and I'm going to just select the src directory as the root directory and click continue. So we are telling Vercel that we have a simple website, no framework, and we are simply going to pick the code from the src directory and just directly deploy it to the cloud. And there are other settings which we don't need right now. So I'm just going to click deploy. Now, as soon as we click deploy, Vercel has pulled out all the code from our GitHub repository. It has set up a machine on the cloud, conceptually speaking, and it has deployed the code. And you can see here that this is what the deployed site looks like. Okay, you can actually click continue to dashboard, and here you can see that we have a preview of what the deployed site looks like, and we also have links to a couple of deployments. So by default, your project name .vercel.app is the location of the deployed website. And let me just zoom in here. So you can see now we have deployed our website. So now we are developing on GitHub Codespaces, and we are pushing our changes back to GitHub. And then we have connected our GitHub repository to Vercel, and Vercel is picking up the GitHub repository, the main branch, and it is deploying it automatically. Right? You can see here that it is deployed automatically. So that is how easy it is to deploy. And the next thing you can do is anytime you make a change, let me come back here in index.html, and let me just change this to about Jovian. And I'm just going to make a quick commit here. So I'm going to stage the change. I am going to commit. And sometimes when I try to commit without a message, it will ask me to put in a commit message. So let me just say change to about Jovian, and let me close that. So now it is committed. Now I'm going to push again, and okay, let's push it. Now the changes are going to get pushed. Now the changes are pushed here to Jovian Career Site Live. You can see that we just changed to about Jovian. And once you push, what happens is you can see that a new deployment is going to be made by Vercel automatically. So you can actually see a history of deployments. You can see just 3 seconds ago, a new deployment was made, and this new deployment was made on the commit change to about Jovian. So on Vercel, welcome to Jovian, changes to about Jovian. So anytime you make any changes to your GitHub repository and push the main branch, or you make changes on Codespaces, push the main branch to GitHub, Vercel automatically picks up the new change from the main branch and automatically redeploys it. Isn't that nice? That all you have to do is just go on coding here and keep checking your live preview. Whenever you're ready, you can just go in and you can just add all your changes, commit them and push them. And once they are pushed, Vercel will pick them up and deploy them. And that is the deployment workflow that you are going to work with, more or less, right? So you go to vercel.com, sign up for an account. Once you sign up, you create a new project and you choose the repository that you want to deploy. It supports GitHub, GitLab, and Bitbucket, and you'll have to connect and give access to Vercel. Then you choose the project root folder. In this case, it is the SRC folder, and then you click deploy, and then it creates a deployment. So it builds your project, deploys to the cloud, and whenever you push new changes to your repository, especially the main branch, Vercel will automatically build and deploy your project. So that creates a very nice workflow. Now, one of the goals in the problem statement was to add some meta tags and improve the previews of this web page. So now we have this Jovian Careers site live.vercel.app. But one thing you'll see here is, if I zoom in a little bit here, you see it says my first web page at the top here, and it also doesn't have an icon. So it'll be nice to maybe get a Jovian icon in here as well. Another thing that you can check is if you try to share this on LinkedIn or Twitter or elsewhere, it's not going to show a nice preview. Okay, normally we expect to see a nice preview of our normally we expect to see a nice preview of any website that we share on the internet. So, but that is not showing up. So normally what happens is when a website is found by Google, or when a website is shared on, let's say, LinkedIn or Twitter or Facebook, they automatically pick up this preview image. There's something that can be configured, and they automatically pick up maybe a title and a description, all of this. So where does this come from? Well, all of this is done using some special tags, special HTML tags called meta tags. HTML meta tags provide information about a web page to search engines and browsers, and they are placed in the head section of a HTML document, and they're not displayed on the page itself. So you can actually use a platform like heymeta.com. You have these tools like heymeta.com to actually check what the preview for a particular web page is going to look like. So let's say if I just copy this my first web page link and put it here, and I check what the preview is going to look like. So you can see here that there is no preview image, and the title of the web page is simply my first web page, which is not very informative, and there is no description as well. So there's no description, there is no image, none of that. On the other hand, most modern websites, so let's say www.jovian.com, if you share this link with somebody on social platforms, or maybe just check on heymeta.com, you'll see this preview image, build a successful career in Trek. This is not there anywhere on the actual page, but this is just for the purpose of preview. And you will see that it has a nice title and it has a nice description as well. So all of that is something that is going to show up automatically. So all of this is achieved using meta tags. So there are several types of meta tags, each with its own purpose. So here are some of the more common meta tags that will be used in most web pages. There's something called a meta char set. This is used to inform the browser what is the character set. There are several character sets. There's something called ASCII, something called UTF, etc. So what is the character encoding that this page is using? So this is often something that is set to UTF-8. Then there is something called the viewport meta tag. This is used to inform the browser how to scale up or down, how to zoom in or out the website on a mobile screen. Again, there is a standard value that is preferred for more modern websites. Then there is this meta name description, and this description is actually picked up by platforms when you share this link, when you share the website as a link. So the description is not actually shown on the page, but it is just picked up as a preview by Google, and whenever you share the platform elsewhere. You can also set a meta author, not particularly useful these days. And you can also set meta keywords and meta robots. Meta robots provide some instructions whether search engines should index this page or not. And meta keywords is used to specify some keywords that were used in the past for search engine indexing, but are not now very less important. Okay. There are also platform specific meta tags. So you can take your URL, your website URL, and make it show a different way on Facebook and a different way on Twitter, for example. So there is this property called OG title. So this is the title that is going to be picked up by Facebook, LinkedIn, and several other sites. OG stands for Open Graph. And there is this property called OG description, which is picked up for description on Facebook. You can also specify this image using OG image. This is the image that shows up here. And finally, you can specify similar title, description, and a card setting for Twitter as well. Okay. So those are all the meta tags that you can have on your website, on your web page. And apart from this, you can also have a title meta tag and a favicon link tag. So the title, this title is not a meta tag exactly. It is simply used to set the title of the page. So this is also important because this is what shows up on the browser tab. And you have a link tag which contains something, a link to an image called a favicon. And that image is the image that shows up over here. So right now you're just seeing a small web image here, but instead, let's say here you have the GitHub logo, and elsewhere you will see the Jovian logo on Jovian. Let's say I open www.jovian.com. You see the Jovian logo. So putting a logo here in the browser tab is done using the favicon. Okay. So what we'll do is we'll go ahead and add a bunch of these meta tags to our web page. So we can take all of these meta tags. We have charset, UTF-8, name, viewport, description, keywords, author, robots, etc. And we are going to add them all to our project. And specifically, a couple of images also need to be added. See, we have this one meta tag called OG image, and that we are going to set as jovianmeta.png. And the file jovianmeta.png is here, so you can download it in case you want to add it. Yeah, this is the image that we're going to use as jovianmeta.png. So I can just save this image to my desktop and then upload it to Codespaces. And we also have a meta image for our favicon. So this is the favicon that we're going to use. This is the icon that is going to show up on the browser over here. Okay. So again, these are not things that you learn in an introductory HTML course, but to build good, practical, modern websites, you need to have good meta tags. Otherwise, your websites are just going to look random on the browser or when people share them. Okay. There's more information you can learn about meta tags here, but these are the tags that we're going to add into our web page. All right. Well, so now we want to add meta tags. So we basically want to add all this code into the head tag of our index.html file. And we know how to do this. We just copy the code, put it into index.html, then stage the index.html file, then commit it, then push it. But before we do that, we're going to take this opportunity to maybe also learn the GitHub collaboration workflow. Because what is going to happen in the real world is that you're not going to directly make changes to the main branch. As you can imagine, let's say Jovian, the website is running, and before we actually push any new changes, we may want to get them reviewed. We may also have a situation where multiple people are working on multiple changes, and if they're all constantly pushing to the main branch, then they may all be just overwriting each other's code. So that is why GitHub has this collaboration workflow powered by branches. So what you do is you have your main branch or your master branch. From your master branch, you create a feature branch. And we'll talk about branches in just a second. And then in that feature branch, you add a bunch of commits. So one by one, you keep adding commits into your feature branch. Then what you do is you create a pull request. So you, using all the changes that you have put into your branch so far, you create a pull request on GitHub. And in the pull request, you can basically list out the changes you've made. The pull request will also have all the code changes between your branch and the main branch, and the team can then review your pull request. So somebody from the team can look at the changes you have made and they can make comments on your pull request. So they may make some comments, and then you can then make more changes, make new commits based on those comments. You can fix the things that are not working as expected. And once all the comments are resolved, somebody from your team can possibly approve your changes. And once your changes are approved, you can then merge those changes into the main branch. Okay, so you can take the new changes and you can merge them into the main branch. And then, of course, we have Vercel set up already. So as soon as the main branch gets changed after all this discussion and review, then it is going to get deployed automatically. So this is how we safely develop software. We take out a branch, which is basically we extract out a copy. Conceptually speaking, we make changes to that copy. We keep adding commits. We then set up a pull request, people comment on it, we make changes to it, we do whatever testing we need. We'll also see how to generate a copied version of our site, which can be used for testing. And then once we are ready, we approve the pull request, merge it back to master, and that is going to trigger a deployment. So that is how the GitHub collaboration workflow works. And it's not just that you will be using a single branch at a time, but here's what might happen, that you may have your main branch somewhere, and then you may start a new branch, you may start making some changes, and then some changes may get added to the main branch from other people, and then somebody else may start another branch, and then your branch may get merged, and then their branch may have to get merged. So this is how the GitHub development workflow works. Anytime you want to build a new feature, you create a new branch, make changes on the branch, get that reviewed, get that approved, merge it back into the main branch. And the main branch is the source of truth for what is going to go live on Vercel or whichever deployment platform you're using. Okay, so this is the workflow that we're going to follow. And the first step in this workflow is to create a branch. So what is a branch? Well, branching is a very fundamental feature of Git and GitHub that allows developers to work on multiple versions of the same code base simultaneously. So you can use it to work on 5 tasks at a time, or 5 features at a time, or 5 different people can use it to work on different features without disturbing each other's code. Okay. And a branch is essentially a separate copy of the code base, conceptually speaking, that you can make changes to without affecting the main branch, which is usually called main or master. So here is how you create branches within Git, or using Git or within GitHub Codespaces. First, we open the terminal. So once again, I go in here, I say view terminal. Now I have the terminal open here, and let me close the sidebar. So the first thing you do is you type git branch, and then you type the name of a branch. Okay, so you'd say git branch, and I just want to add meta tags here. So I'm just going to call this branch add-meta-tags. So you always use lowercase letters like add-meta-tags, all lowercase, and you always generally separate by hyphens. You can also separate by underscores if you want. One other convention is to also maybe put your username before the branch. So I could also create the branch as such, Akash /add-meta-tags. But this is a good convention so that multiple people don't end up creating branches with the same name accidentally. In my case, I'm going to just use the shorthand AA for myself. So AA/add-meta-tags, that's what I use at Jovian. Okay, so we are creating a branch called AA/add-meta-tags. Okay, the slash does not have any special meaning. It is simply a separator that I'm using. I could also have said AA-add-meta-tags and it would be the same thing, but it's just a little nicer to look at. Okay, AA-add-meta-tags. So now I'm creating a branch. So a branch has been created, but we are still on the main branch here. You can see here, I'm still on the main branch. So now we need to switch to this new branch that has been created. Now the way to switch to a new branch is using the git checkout. So you say git checkout and then you type the branch name. So AA/add-meta-tags. Now we have switched to the branch AA/add-meta-tags. Great, and that is something that is displayed here as well. Now that we have switched to the branch, we can now start making commits into this branch. So here is how I might go about making some commits. So I might first, let's see here. I might first maybe just replace the title and the fav icon. So let me just grab the title and the fav icon here. And I'm just going to replace that over here. Okay. And I will just test that. So now when I reload the page, you can see that now we have Jovian careers, and okay, this still doesn't have the fav icon. Maybe the fav icon will come in when we actually deploy, but looks like at least the title has changed. Okay, so I've made one significant change. So I'm just going to stage this change. I'm going to say added title and fav icon, and I'm going to commit. Okay, I'm not going to push my branch yet. I want to make a few more commits before I push my branch. Okay, then maybe I might figure out, okay, I might talk to the marketing team. I might figure out what they want as the OG and the Twitter meta properties. So I will add those. And then I might talk to maybe the engineering team and figure out that, okay, what are the other meta properties I require. Let me grab all of the remaining meta tags and let me come in and let me just paste them here. Okay, so I'm just simulating an example where you will be making small changes step by step and making multiple commits. So I've gone ahead and made these, and of course now for this OG image and for this Twitter image, I need to actually upload this image file. And I also need to upload this favicon file. Okay, that's why the favicon is not showing. So I'm going to, let me first add the meta tags. I'll create another commit where I upload the files. So again, I can go in here. I can say add the changes. I can commit. So let's say added meta tags. I can commit. Great, perfect. And now I can go ahead and I can actually upload the files. So I can come back here. I can say right click, upload. Let me grab Jovian meta.png, Jovian favicon.png, upload them. They are added as well. And once again, I can go in, or I can also do this from the command line. So I say view terminal and I say reset. And let me just do git status. Okay, looks like there are a couple of new files. So let me do git add dot and let me do git commit -m, add favicon and meta image. Okay. All right. So I've not pushed my changes yet. So I have a bunch of commits here on this particular branch. If I just check git log, or I can actually just, if I just want to see the list of changes, I can say git log -1 line. Okay, so my branch AA-add meta tags is at the commit add favicon and meta image. Before that, I have another commit. Before that, I have another commit. So I've made a bunch of commits. Now, once I have made a bunch of commits, I can then open a pull request. So to open a pull request, here's what I need to do. First, I need to push my branch or my changes to the remote repository. And the way I can push them is by saying git push origin followed by branch name, AA-add meta tags. Okay. Of course, I can also achieve the same thing by just clicking publish branch here, but I'm just going to do it from here. And once that is done, you can now see that a new branch will have been pushed to the GitHub repository. How do we verify that? Well, if I open the GitHub repository and I just reload the page, you can see there's this message here that this this had recent pushes. Of course, there's this trigger, but you can also see here that we have 2 branches now. So earlier this was just saying 1 branch. So I can actually go and select the other branch. So the commits that I've made together, I can package them as a branch, and I've pushed it to GitHub. And now I have this on the main branch. You can see here that src index.html doesn't have any of the meta tags. My main branch is unaffected. But if I change to the branch add meta tags, on this branch, you can see that all the tags are present. Okay. So this is how you push branches. Now, what you can do is you can make more commits. You can push the branch again. So you decide what you want to do. Typically, any small change I make a commit. And then once I have a bunch of small changes that are significant enough, I push the branch. Okay. But coming right back. So now we have pushed. Let me come back to the main branch here. Now that we have pushed the branch, the next step is to create a pull request. So how do we create a pull request, and what are pull requests? So pull requests are a way to propose changes to the code base and get them reviewed by other developers and then get them merged back into the main branch. All right. So let's create a pull request. So first we are going to come back here. We are going to go into the pull requests tab. And into the pull request tab, again, you can see that there is notification here. GitHub tries to be helpful where it tells you that if you recently pushed a branch, it'll ask you if you want to create a pull request. But in case this notification is not showing up, you can click new pull request. Okay. And now you can select the base branch, which is where you want your changes to eventually go, and the branch where you are making your changes, which is add meta tags. Okay. So now I've selected that these are the 2 branches, and I can actually verify what are the changes. So it seems like from the main branch, I want to remove this existing title and I want to add a bunch of these meta tags. And seems like I also want to add a couple of image files. Okay. So I can review the commits that have been made on this branch. I can review the changes between the main branch and this new branch that I'm proposing. And then I can click create pull request. And here I can give the pull request a name, and typically you want to give this a description of the change. So added meta tags, title, and favicon. And it's also a good idea to maybe provide more detailed description of the changes. So you can say changes. One is added or updated the title tag. Then you can also mention, okay, added images for fav icon and meta poster or meta banner. Then you can say added meta tags, including OG and Twitter tags. And finally, you can also mention added the fav icon link tag. Okay. Now let's say you've tested these changes. You might also want to say what you've tested. So test cases checked. So you can say something like verified the title showing up. And maybe you might want to verify later and add later that you've verified the fav icon showing up and you verified the meta tag showing up. Okay. And then you click create pull request. So that's great. Now the pull request is created. And now somebody else on your team who is a collaborator on this repository can go ahead and review this pull request. So let me first go ahead and add a collaborator here. So I'm going to go into settings. I'm going to go into collaborators and I'm going to add a collaborator here. Let me just add Akash NS and I'm going to invite this collaborator. Let me go back to the pull request. Okay, so this pull request now has a description and there is this files changed which contains information about the files that have been changed, so people can review that as well. It also contains information about the commits that have been made. So now let me go in and log in from a different account. So I have a different account logged in here and I'm just going to accept the invite first. So I've been invited as a collaborator here. So I'm going to accept the invite. So anytime you invite somebody as a collaborator, they get sent an email and they can accept the invite. Okay, now that I've accepted the invite, I can go here into the pull requests tab and I can go check the pull request. I can see that, okay, Sydney Jovian has invited me or has created this pull request. I can check, okay, these are the changes that have been made. I can maybe go in and then I can go in and maybe leave a comment. So let me say, for example, I don't like this title. I want it to be a little longer. So I can say, make the title longer, please. Maybe at least 24 characters. Okay. And then I can just start a review and I can add a bunch of these comments. So I can add a comment maybe about the meta title here as well somewhere. Let's see. This can be improved a bit. And so on. And once I'm done with reviewing, I can just say, I can request some changes or I can approve and I can click submit review. And once I've clicked submit review, then these changes have been pushed back and now Sydney Jovian can once again go through the changes, go through the comments that are made and make those changes. Okay. So again, we are just trying to implement this workflow here where you create a pull request and then somebody posts a bunch of comments and then you create new commits to fix those comments and you keep repeating this process till they're happy with it. Okay. One other thing I want to show in this process is that if you see there is a Vercel bot that has added a comment here. What Vercel has done is whenever Vercel notices a pull request in your GitHub repository, it takes the code within that pull request and it automatically creates a preview deployment. So I can click this visit preview and I can actually preview the changes. Okay, I can see here that now it says Jovian Careers instead of my first web page. And there seems to be a bunch of, this image seems to be showing here as well. And there are no changes in the actual page. But if I were to maybe take this and maybe go into metatags.io, a platform for checking meta tags, I can actually check that, okay, it is showing Jovian Careers and it is showing a description here. Image is not showing up. I can investigate why the image is not showing up, but it looks like the meta tags are now showing up. Okay. So this is one of the nice things about using Vercel. What it takes your branch, your pull request branch, it deploys that and it adds a link to that without disturbing your original page. So you can see Jovian Careers site. This is like that branch preview, but your original site, which is over here, Jovian Careers site. still says my first web page. It is not updated. So your main branch is safe, but for your pull request, you have a preview deployment that you can study. Okay. All right. So let's go in and fix these quickly. So I'm just going to go in and fix these comments. So there is a comment here that says make the title longer, please, maybe at least 24 characters. So I'm just going to add maybe here, build a successful career in tech. And I'm going to add the same title here back in the OG title like that. Okay, I've fixed the title. Learn more about job openings and submit your application now. Well, I don't think I'm going to update that. I think I'm happy with the way things are here. So I'm just going to click commit and let me see. I'm just going to stage my changes and let me say updated title. And I'm going to click commit and I'm going to publish the branch. So now once a pull request has been created, anytime you publish the branch again, the pull request will automatically be updated. Okay, so let's come back here and let's reload this page. And you can see that this new commit has been added and Vercel is automatically going to take this new commit and it's going to deploy it. So it's nice like that. So if I go back and check the deployment this time, it has not just Jovian Careers, but it has Jovian Careers build a successful career in tech. It has the full thing that I've mentioned. Now I can go in and I can say, okay, resolve this conversation. So this is fine. And then here I can say, I think this is fine as it is. And I can resolve this comment and resolve this conversation as well. Okay, so this is what you want to do. You want to resolve all the comments and then the reviewer may go back and make some more comments and then you resolve those comments and so on. And the reviewer and you both can use the preview deployment to test out your changes, preview the changes live as well. Okay, now the reviewer can eventually come back later in the day or maybe the next day and see that, okay, all their changes have been resolved. So then they can go ahead and they can approve the pull request. So they can go back into this files tab and they can go in and they can approve the pull request like that. And once a pull request is approved, then the changes can be merged back into the main branch. Okay, so far, so far we are still at this stage where we have deployed, we have done a preview deployment and the pull request has been approved. But to merge it back, we can come back into the pull review page, the pull request page, and at the bottom we can see that once all the approvals have been received, and you can set conditions this at the repository level. Then you can click merge pull request and you can give it a commit message and a commit details, and then you can click merge, and that is going to now merge this to our main branch. Okay, so now this has merged, and now if I come back into the code tab and I see the main branch, you can see here now it has this new commit called updated title. So this is the workflow that we have. We created a feature branch, added some commits to it, pushed the branch, created a pull request. Then we invited a reviewer to comment. The reviewer commented. We made the changes. We also looked at the preview deployment, which Vercel automatically gave us very kindly. And we made sure that everything was working fine. And finally, the changes were then merged to the main branch. And of course, Vercel picks this up again and does another deployment. So now if I go back and just reload the main Vercel page, you can see that now the Fev icon is updated, the title is updated, and I can also check. So there's a place here that you can check meta tags. I believe it's called kmeta.com. Yeah. So I can also check all the meta tags now on Jovian Careers website, live.vercel.app. So now our Jovian Careers website has this nice title that is going to get picked up by Google, Facebook, Twitter, etc. It has this nice image that will show up as a link preview when you share this link on LinkedIn or elsewhere. And it has this nice description over here as well. Learn about job openings at Jovian and submit your application now. So great. So we learned about meta tags, but alongside we also learned about the GitHub collaboration workflow, which is branch, pull request, get it reviewed, iterate on it, and then merge it once you have received the reviews. Okay. So that's about branching with Git. And that is about creating pull requests. And I would encourage you to exercise this a little bit. So create multiple pull requests with minor changes and then verify that each pull request gets its own preview deployment. So if you have 5 pull requests, there are going to be 5 preview deployments. So Vercel gives you unlimited preview deployments for free. And then verify that the main site is not affected till a particular pull request is merged. Okay. Also, one thing that you can try to do is try to see what happens if you have 2 pull requests and then you merge one and then you try to merge the next one. So these are some exercises for you to try out. Git is a very applied skill. So you have to try out all these things. Whatever questions you have, just try it. Within 5 to 10 minutes, you'll actually have your answer. Now, let us talk about keeping your branch up to date. So here is a scenario that might happen. We already have 2 users now. We have 2 collaborators. One is Sydney Jovian and the other collaborator is Akash NS. So that's why I have these 2 windows in black and white. So here I am signed in as Akash NS and here I am signed in as Sydney Jovian. Of course, the repository still belongs to Sydney Jovian. We are both collaborators on it. Now, let us try to make changes in such a way that 2 people are working in parallel and once changes get merged into main while the second is still working. Okay, so let's do this. Let us first go into this code. So this is on the user Akash NS and I am going to create a code space to start editing. And it's going to take a second or two to set up the code space, but once it's done, I should be able to start editing some things here. Okay, so inside src, I have index.html and let me just go in here and let me just change this to, let me edit the title again. Let me change this to welcome to Jovian. And let me change something in the description. Let me remove highly reputed. Let me just make it most reputed technical university. So I've made a couple of small changes here. And let me also remove the word Jovian from the names of the programs. Let us just call it Full Stack Developer Bootcamp and Data Science Bootcamp. And let me just commit it. So let me go into source control. Let me add the changes and let me say made some changes to index.html and let me commit it and let me sync the changes. Okay, I have synced it. It looks like I made those changes on main, right? So let me now create some more changes and let me make those on a branch because normally this is not something we should be doing. We should be creating a branch. So let me add back, let's say, let me add back the word Jovian here. Let me add back the word Jovian here. And let me add the word open job opportunities here. And this time I'm going to first create a branch. So let's see. Let me create a new branch. Let me call this branch open job opportunities. And now the branch has been created. And now I'm on the branch. Now I can add my changes to my branch and let me commit them. So added open job opportunities. Okay. And now let me publish the branch. So what I've done now is I have made some changes on main and that will just go out to everyone for sure. But then I've also created a branch out of main, which I'm going to then create a pull request on. So I can then come back here and looks like, okay, this new branch has been pushed. Let me click compare and pull request. And let me just say added open job opportunities in index.html. And that's the same description for now. Let me create a pull request. And the changes that have happened here are simply, well, from the main branch, I have simply added the word Jovian back and I've added open job opportunities here. Okay. So just to show you what happened, what we did was we had the main branch and then from the main branch, we made another commit. So we made some changes onto the main branch. This was done by Akash NS. So this was the main branch. Then we branched out of the main branch and made one commit. And of course, we could have made multiple commits on that branch. So this branch is the open job opportunities branch, right? And this branch has been made by Akash NS. And we've set up a pull request for this branch as well, right? So let us call this pull request 1. Now we've set up a pull request 1 called added job opportunities in index.html. Now let us come back to Sydney Jovian. Okay. And let us go back here to the main branch first. So there is a selector here that I can use to go to the main branch. So let's say here, I've just checked out the main branch. Now the main branch on Sydney Jovian is a little bit behind my old branch, the branch that has been created by Akash NS. So let's say Sydney forgot to pull the latest changes before working on a new change, right? Let's say Sydney is working on some changes related to the dates of the front-end developer, back-end developer, etc. So what Sydney does is creates a new branch to make his changes. So I'm going to say branch, create a new branch, and let me just say job date changes and create this branch. So a branch has been created by Sydney for his work. And now Sydney is going to make the changes to the jobs. Let's say this is March, instead of March 3rd, this is March 13th. Instead of Feb 1, this is Feb 11. Instead of December 22nd, this is December 20. And here we change the salary to 85,000. Okay. And now let me commit these changes into the branch. I have staged them. So job changes and commit. And let me publish this branch. And now let me again come back here and let me create a pull request. Okay. So once again, these are job changes. So job date changes. And this is again something that I would want to merge. Okay. And the only changes here are the changes within the dates. So let's once again recap what's happening here. So here Akash NS has first made a change to the main branch itself and pushed it, and then created a new branch and created a pull request on top of it. Then Sydney forgot or did not have a chance to pull the latest changes on main. So Sydney created a few changes from the last version of main and then made a couple of commits, let's say, and then set up a pull request. Let's call it PR2. Okay. So already things are a little out of hand. Sydney's main branch on his own computer is a little bit behind, and Akash's main branch is a little bit ahead. And of course, this is also the main branch on GitHub itself. So that's why you have Origin has its own main branch, but Sydney has its own main branch, which is a little behind. And now there is this pull request. And now one of these pull requests is going to get merged. Let us say the pull request number 1 gets approved. So let's say somebody on the team goes ahead, reviews the pull requests that are all present. So let's say they go into the pull request created by Akash NS and they go ahead and approve the pull request. Okay, so they just approve it and they just merge that pull request. So now what has happened is that Akash's changes have gone into master. So now we are at the situation where this pull request has been merged back into master. And however, this pull request is still tracking the old main branch. So now what we need to do is we need to update this second pull request to show changes based on the new main branch. Okay, so here's what we need to do. We need to take the changes in the main branch and then incorporate them into the currently open pull request. How do we do that? Well, here is a step-by-step process. First, we check out the main branch, then we pull changes from the main branch, then we check out the feature branch, and then we merge the main branch, and then we push the changes. Okay, so we'll do it step by step and it will make more sense. Okay, so now I am here on Sydney's branch, and I'm on Sydney's pull request branch. So I'm on the branch which Sydney has created for pull request number 2. And this is based off of a main branch, which itself is very old. Okay, so I'm going to show this on the terminal, but you can do the exact same thing from your from the user interface as well. So first, I'm currently on the branch job date changes. I'm going to switch to the main branch. So git checkout main. Okay, by typing git checkout main, I have now switched on Sydney's Codespace. I've switched into the main branch on Sydney's Codespace. Now, of course, Sydney's Codespace main branch is behind the main branch on the server. We already know that because one direct commit was made and then one pull request was merged. So I can do, the first thing I can do is I can do git fetch -- all. What that does is that fetches the changes that are there on the remote, but it does not apply them yet. So it does not pull the changes. It simply fetches information about the changes. Again, more terminology, I know, but right now what we know is we have now fetched information about what are all the branches that are present on the remote server and where are they compared to the branches that are present on this server. Okay, let me now reset and let me type git status again. And now I can see here that your branch is behind origin main by 8 commits. So it looks like I'm fairly behind because a bunch of other pull requests were merged. But here's what I can do. I can say git pull origin main. So now what I'm saying is that I have my local main branch, which is a little bit behind, and then there is this origin main branch, which is ahead. If I type git pull origin main, then all my changes are going to get my main branch is going to get up to date with the origin. Okay, so what has happened now is that Sydney's local copy of the main branch has become up to date by with the main branch on GitHub. Okay, that's fine. Now let us come back to our job openings branch. So I can just type git branch to see the names of the different branches that are available, and I can switch to the branch. So I can say git checkout job date changes. Okay, now I've checked out job date changes. The trouble is my local main branch is now up to date. My local main branch is now up to date with what is there on GitHub, but my job main branch, but my jobs feature branch is still pointing to that old main branch or that old main commit. Okay, so what I need to do is I need to pull in these new changes into my job branch. Okay, so now we do git pull, or not pull, well actually we need to merge in these new local main branch changes into the job branch. So we say git merge main. So what we're telling Git now is that I'm on this job date changes branch. Take the latest changes from the main branch on my computer, which is already tracking the latest changes from GitHub, and bring all those latest changes back into my feature branch. Okay, so I type git merge main, and this will ask me to then type a message. So I'm just going to say merge main into job date changes, and once you type the message, you can just close. And now magically what it has done is it has taken all the changes that have been made in the main branch on GitHub, and we first pulled that into the main branch on our computer. Now all those new changes have been put into our feature branch, which is job date changes. Okay, and you can verify that. Here is how you can verify that. You can see that we have Jovian Data Science Bootcamp mentioned here. So that is there. You can see that we have most reputed technical university. So all the changes that were made by Akash have now been incorporated. So what we have done essentially is we have taken the changes that have come newly and we have incorporated them into the second pull request branch. Okay. One last thing to do here is that these changes are still local on our code space. So I need to push these. So I need to say git push it to the pull request. So git push origin job hyphen date hyphen changes, and this should get pushed. Okay. Finally, now we can come back here and we can see that job date changes has now been updated. Job date changes has now been updated with the merged changes into the main branch. Okay. And now it is tracking against the latest main branch that is present. And now somebody can come in and somebody can approve it. And then this can be merged in. Now we can go in and now we can merge this change and put that back. Okay. So I know that there was a lot going on there, but I'll just first revise this. So what we do is whenever new changes have come onto the main branch on GitHub and we want to incorporate them into our feature branches, here's what we need to do. First, within our code space or wherever we are doing our development, first go to the main branch, our local main branch using git checkout main. Then we get the latest changes from the remote by running git pull or git pull origin main, so that our local main is tracking at the same place where our latest changes are on GitHub. Then we check out our feature branch. We say git checkout feature branch name. Then we merge in the changes from the main branch that we have locally now into our feature branch. And finally, we push these changes to the remote repository. So we take our feature branch and push it to remote so that the pull request gets updated. Okay. So this is the workflow that you will do over and over as a developer. You'll check out the main branch, git pull, check out the feature branch, merge the changes from the main branch, and then push your feature branch back to GitHub. And these steps will ensure that your feature branch is updated with the latest changes from the main branch. Okay. So as you have created a feature branch and you made some commits on it and made a pull request, if new changes have come onto the main branch, you can simply pull those changes in by following this workflow. And then you can push your main branch back, push your feature branch back, and your pull request will get updated. And then the merging will happen seamlessly. Okay. So that's how merging works. This is called, you're basically merging changes from the main branch into the feature branch. And Git is smart enough that if the changes were made within the same file, but to different parts of the same file, then things will work out just fine. Git will be able to combine all those changes from multiple users, multiple commits together. Okay. And again, I encourage you to practice this. Create a branch, make some changes, create a pull request, create another branch and make some changes, create a second pull request. Now approve and merge the first pull request, and then update the second pull request to incorporate the new changes from the first pull request, and repeat that process a few times using the command line and using VS Code's user interface to see if you understand how this whole thing works. Okay. Now, there are certain cases where two people in two separate PRs have updated this exact same line of code, in which case there is going to be something called a merge conflict. So let us try and simulate a merge conflict situation now by both users updating just the title of the page. Okay, so let's do this. Let us first go back here into the code space that is being used by the user Akash NS. And let me open up a terminal. I'm just going to do everything on the terminal so that things are super clear. So we are currently on the branch open job opportunities. I'm going to first check out the branch git checkout main. Okay. Now I'm on the main branch on my Akash NS code space. Then I'm going to run git pull origin main so that I have the latest changes. Perfect. I am going to get the latest changes on the Sydney account as well shortly. But now I'm going to create a new branch. I'm going to create a branch git branch AA-title change 1. Okay, I've created a new branch title change 1. I'm going to check out that new branch git checkout AA title change 1. So now I've checked out a new branch. So I have the latest main branch. From the latest main branch, I've checked out a new branch. Now I'm going to come in here and I'm going to change the title of the page, which is, I'm just going to change it back to Jovian Careers. Okay. So I'm changing the title of the page to Jovian Careers. That is one change I'm making. And I will also change here, welcome to Jovian to about Jovian. So two changes I'm making. I've changed the title to Jovian Careers, and I have changed about Jovian to welcome to Jovian to about Jovian. So those two changes. And you can verify these changes by using git diff. I can see that those are the only two changes I have made. Now I'm going to commit these changes. So I'm going to say git add dot. I'm going to git commit -m, change title and about Jovian. Okay. Now I have committed my changes onto my local branch. And now I'm going to push my local branch to GitHub. So I'm going to say git push origin AA-title change 1. So now my branch, which is based on the latest main and has a couple of changes, one to the title and one to about Jovian, has been pushed. And now I can create a pull request using this branch. Okay. Now I can go in here and I can say create a pull request. I'm going to just call it change title. So I've changed title to Jovian careers and then change description heading to about Jovian. Okay. And I'm going to create a pull request. Perfect. So we understand this flow so far. We created a branch, we made some changes, we committed and we pushed it, created a pull request. And we can verify that it contains only these two changes. It contains a change Jovian careers and it contains a change about Jovian. Perfect. Now, let's say before this pull request was merged, Sydney was also working on some changes where he's going to change the title. So I'm going to say file, view terminal. I'm opening up the terminal again. Let me reset it. Let me also go back here to the master. So let me say git checkout main. So now I'm on the main branch back. Let me also do git pull origin main. So I have the latest version of the origin main. Okay. So in the latest main, our title still has Jovian careers, build a successful career in tech. And the title here for the description is still welcome to Jovian because the changes were made in a pull request that is not yet merged to main. Okay. So I hope this is clear to you that our main branch is still has the old title and the old heading. Okay. Now I'm going to create a new feature branch. So I'm going to say git branch sy for Sydney, title change to. Okay, fine. And now I am going to come in here and I'm going to remove this part. Okay, so I'm just going to remove the part build a successful career in tech. I'm going to keep the part build a successful career in tech. So maybe two people got different instructions. Akash has made the change to about Jovian. He was asked to shorten the title. And Sydney also got the instruction to shorten the title and he changed it to build a successful career in tech. And maybe I also go in here and change something about the job opportunities. So I don't want it to say open job opportunities. I want it to say job openings. Okay. And I will also check out this branch, git checkout sy/title change to. And once I've checked out the branch, I'm going to add the changes. So git add dot. Then I'm going to say git commit -m, change title and job opportunities. Okay, now I've committed. Now I'm going to push this branch. So I'm going to say git push origin sy/title change to. Now my branch has been pushed to the origin, which is GitHub. Now I can come back here and create a pull request. And here I am changing the title. So change title and job opportunity. So here I'm changing the title to build a successful career in tech. All right. Yeah, so the title is changed to build a successful career in tech, and then change the job section header to job openings. Okay, let me create a pull request here. And let's see now. So here now, there are two changes on the title and on job openings. Here also there are two changes on the title, but a different change to the title and on the job openings. And both changes are made against the latest version of master. Now let us merge one of the pull requests. So now let us go in here and let us merge this first pull request. So what will happen is that by merging this pull request, which changes the title to Jovian Careers, in our main branch, we are going to get back Jovian Careers as the title. Okay, so I'm going to go in here and I'm going to check, click merge pull request, confirm merge. And the pull request has been merged, and I can verify if I go into code and check the main branch and check index.html, it is going to have the change title Jovian Careers. Okay, so now the first pull request has been merged, the title of the page has changed to Jovian Careers, and the header of the first section is changed to About Jovian. However, obviously, for Sydney, the title of the title of the page is whatever they have set in their feature branch, and the heading of the first section is Welcome to Jovian and not About Jovian. And of course, they've also made an additional change called Job Openings. So now Sydney's feature branch is behind the main branch on GitHub. So Sydney needs to update their feature branch. So let's update the feature branch step by step. So I'm going to open the terminal again. I am going to reset things. And remember the step-by-step process for updating the feature branch. First, you go to git checkout main. First, you get to the main branch, because our local main branch on Codespaces is behind the main branch on origin. Then we can check using git fetch -- all, or just git fetch how far behind we are. Okay, so we can say git status to check that we are behind origin main. So we are behind the changes by 2 commits. So let us run git pull origin main. So now we are pulling the changes from the origin main branch on GitHub to our code space on the Sydney code space. Great. So now our main branch is up to date, but our feature branch is still tracking the old version of the main branch. Now we go back to our feature branch. So let's check the name of the branch. Okay, the feature branch is sy title change 2. So git checkout sy title change 2. And by the way, you can verify here that so far we are on the main branch, and on the main branch it says Jovian Careers, which is the change that had been made by Akash Innes. And the title of the first section is About Jovian, which is also a change that was made by Akash Innes. As soon as we go into the feature branch, now we have the title that was set by Sydney here. And now, of course, we have Welcome to Jovian, because this is tracking the old main branch. And we have this job openings here. Okay, so now we need to merge in the new main branch that we have just pulled in. So we say git merge main. Let me just reset that and type that again. Git merge main. And here is what happens. Okay, finally, we've done all this setup to get to a point where when I try to update my feature branch using the new changes that have come into the main branch, I run into an issue because both of us are trying to update the same line. Akash Innes has updated. So there are two things. See, you have a current change, which is the change in my feature branch. So in my feature branch, I have updated the title to Build a Successful Career in Tech. However, when I try to merge in the main branch that has come from GitHub, the latest main branch, because of some other pull request, has the title Jovian Careers. So both the main branch and my feature branch have been independently updated on this one particular line. And you can see only this one particular line is an issue. This becomes About Jovian as expected, no issues here. And this becomes job openings as expected, no issues here, right? So this change came in from the main branch, no problem. Because we didn't change it in the feature branch. This change came in from the feature branch, no problem, because it was not previously changed in the main branch. But this change was made in the main branch as well, which is called Jovian Careers. And this change was made in the feature branch as well, which is called Build a Successful Career in Tech. So this is what Git does. It inserts this like random characters here, which basically tell you that what you have on your current branch and what you have on the main branch. And you can either edit it manually, you can kind of erase all these characters, or you can just use one of these buttons, whether you want to accept the incoming change, which means the incoming change is what is coming in from the branch you're trying to merge in, which is what is coming in from main, or you can accept the current change, which is what you have in your feature branch, or you can keep both changes. So here's what I'm going to do. I'm going to click accept current change. So I want my feature branch change to override what has come in from the updates in the main branch. So I'm going to click accept current change. And now in my feature branch, I have resolved the merge conflict and I've overridden the change that was made in the main branch. And now I need to create another commit. Okay, so now I can say git add dot git commit -m resolved merge conflict. Okay, now I've made this change. I need to now push my feature branch to update my pull request. So now we can say git push origin sy title change to. Okay, and now I can go back here and reload my pull request. So if I did not make this fix this merge conflict and I tried to merge this pull request, it would say that the pull request cannot be merged because it is conflicting with the latest version of main. But now that I've fixed this merge conflict, you can see that I have said that from the main branch, I want to change Jovian careers, which was the latest version of the title on the main branch, to build a successful career in tech. And I want to change open job opportunities to job openings. Okay, and then we can go ahead and merge this pull request. Right, and that's it. So now we should, on the main branch, we should have incorporated changes from both the places. Right, so if we look back at the pull requests, we have closed a couple of pull requests. One of them changed the title to Jovian Careers and About Jovian, which merged first. The second one changed the title to Build a Successful Career and changed the job section header to Job Openings, which merged second. And while merging the second one, we chose to override the changes from the first one. We could also have chosen to keep it. At the point of the merge conflict, we can decide what to keep. So the end outcome of all of this is going to be that if we just check the title here, so the title becomes Build a Successful Career in Tech. We have About Jovian. This came from PR1, from the PR by Akash and S. We have Job Openings. This came from PR2, the PR created by Sydney Jovian. And this is how you reconcile changes. Okay, so just to recap, how you resolve merge conflicts occur when Git is unable to automatically merge changes from two branches. And this can happen when two or more people have made changes to the same file or the same line of code in a file, and the changes made in one branch conflict with the changes made in another branch. Okay, so these are the steps to fix a merge conflict. So when there is a merge conflict, VS Code will display a notification in the bottom right corner and will also show a way to merge changes. There you can see the conflicting files. So you can see it like this, and you can have multiple files. You can have multiple conflicts within a single file. And then for each file, you can choose which changes to keep and how to select the right version. And once you have resolved all the merge conflicts, you need to make a new commit, and then those changes can be pushed safely to the remote repository. Okay, and just to make it super clear, I'm also going to draw this out here for you. So here we have the origin main branch. So this is I'm calling it the origin main. Okay, and based on the origin main branch, in each of our code spaces, so let's say this is the code space for Akash and S, and this is the code space for Sydney. Based on the origin main branch, each of them has their own main branch. What Akash and S did was first make a change to the main branch directly and then push that back to origin. So that's how origin got updated. Then Akash and S created a feature branch and then created a pull request from the feature branch called PR1. Then Sydney, based on the old version of the new of the main branch, not using the new version of the main branch, made some changes and created a pull request called PR2. Then we merged the changes from PR1 into the main branch. So This PR1 is tracking a side branch, and we merge those changes back into the main branch. So now the main branch is in conflict. So these two cannot be merged. There's a conflict because both of them have edited the title. So then here's what we try to do. Into our main branch, we try to pull in these changes. So into our main branch here, we try to pull in our changes, and we try to get a new version of the main branch. Then we try to merge those new version of the main branch back into our feature branch. And that is when we resolve the merge conflict. And then we pushed our feature branch back. And now the feature branch was compatible with the main branch. And so these could be merged together. Okay. I know it's confusing. You have to work it out on paper by yourself. You have to try to create a couple of pull requests. You can also go through this explanation again. But only when you do it, you realize it. But all said and done, what we've been able to achieve is we've been able to resolve a merge conflict. All right. So that is the final topic that we are looking at today, resolving merge conflicts. There is another optional topic on using Git locally. I will not get into it today because we've covered a lot of material already. We have looked at a bunch of different things, but there is a way for you to use Git locally. What you can do is you can download Git on macOS or on Windows or on Linux. So you'll get this Git command line tool on your computer. It will look something like this. Git ---- version. It will show you Git. Okay. Then you can you'll need to configure Git. So you'll need to configure a username and you'll need to configure an email before you can start creating repositories, making commits. Now what you can do is you can either create a repository and push it to GitHub, or you can get an existing GitHub repository down onto your computer. If you want to first create a repository on your computer, that is done using the git init command, and that will create a new directory called .git in your present working directory. And then you can make commits locally on your computer, and then you can add a remote repository on GitHub, and you can then push your changes to the remote repository. So there are some instructions here. And you can also, if other changes are made on the repository online, you can pull those changes back. Okay, so that's one flow where you create a repository on your computer, add some commits to it and push it to GitHub. The other flow is that there is an existing repository on GitHub. In that case, to get the first version of that repository, you do something called a git clone. Okay, so more terminology. You clone that repository, which means you get your first version of that repository. Then you can make commits into that repository, and then you can push that repository back onto the cloud. Okay. So I've linked to a tutorial here that you can go through in case you want to use GitHub on your computer. So follow this YouTube tutorial. It's about 40-50 minutes long, and it will get you through all of these as well. But here is where we are going to wrap up today. So here's what we looked at. We looked at using GitHub repositories to share your project source code. And the simplest usage is very simple. You go on github.com, you click create repository, put in some information, add a README file, add a gitignore file, add a license file, and you create a repository. Very straightforward, right? So the simplest way to create a repository is just to go on github.com and create a repository. Then opening up a GitHub repository on Codespaces is also very straightforward. You just go onto the repository page, you click the code button, and you say edit in Codespaces. So till now, there's no Git commands even that you need to run. You just have to open up a Codespace, and you can use VS Code for development. Then while you're developing the website using Codespaces, you just make changes. You can upload files or you can create new files, and you can add code within those files. And you can then preview them using the live server extension on Git. So the live server extension within VS Code can let you preview changes while you are developing. That is again fairly straightforward. The next step, now all of this is still happening on the main branch, the single branch that you get, is to create Git commits. So what you do is you take some changes you've made, you first stage them, and then you take those staged changes and then you commit them. So you record a new version locally, and then you push those committed changes back to GitHub, and that way the GitHub repository gets updated. So always remember this picture. What you do is you do some local development, and then you push the changes back into the remote server. You push the changes back into the remote server, which is GitHub. Okay. Then we learned how to deploy a website to the cloud directly from GitHub using Vercel. And again, it's really simple. You just go to vercel.com, sign in, connect it to your GitHub repository, and then just click deploy. And every time the main branch is updated, which means every time you push some changes into the main branch, then your repository is going to get updated and your website is also going to get automatically deployed. Very easy. And you can also connect a custom domain if you want. So all of this is largely enough for working on personal projects, but we also have the GitHub collaboration workflow. So what happens in the GitHub collaboration workflow is that on your code space, you take a branch out, you make some changes within the branch, you make some commits within the branch, you push that branch to GitHub, then you set up a pull request. And once you set up that pull request, then somebody else can review that pull request. And Vercel also creates a preview deployment without affecting your main branch. And once that pull request is approved, you can merge that pull request back and the main branch gets updated. And so a new version of your project gets deployed automatically by Vercel. So that is a safe way for you to work on multiple features at a time without affecting the main branch, without affecting the main deployment. And whenever you're ready to bring things back, you can merge, you can approve that pull request, or somebody else from your team can approve the pull request and bring the changes back into the main branch. Okay. So that is the GitHub collaboration workflow, which is also fairly straightforward. Create a branch, make some commits, create a pull request, get it reviewed, keep iterating on that branch. And finally, you merge those changes after the pull request is approved back into the main branch. Okay. Now, where it starts to get complicated is when you have these merge conflicts, when you have to keep your branches up to date and there are conflicts where multiple people can have updated the same file. Now, although we've covered it today, don't worry if that does not make sense right now, because that's not something you're going to run into immediately. And that is something that we are going to cover at a later stage multiple times. So you will become familiar with the flow over time. Okay. So, but how it works is, you have to first get the latest changes from the main branch onto your code space, then go into your feature branch and pull in those latest changes from or merge in those latest changes from the main branch into your feature branch, and then resolve any merge conflicts if they show up and push your feature branch back to update your pull request. And that is how you keep your pull requests up to date. Okay. It's complex, no doubt, but only when you do it a few times, you get used to it. So all the code for the tutorial is found here. You can find finally, from this point on, we'll just be using GitHub repositories, and you should also just be using GitHub repositories for all your work going forward. So you should do that. And you can check out the finished site here as well, which contains all the meta tags, etc. in place as well. So we also looked at meta tags and how they can be used to set up a preview image, some description, and a preview title when a link is shared online. Now, Git can be confusing because of all the various terms and commands, but it does become second nature with practice. I still look up commands on Git because even after using it for 15 years, there are so many terms that I often find myself at a loss in terms of what I need to do. But in particular, just try to remember these common workflows. When the simplest workflow is you make some changes, you check those changes using Git diff or using the Visual Studio Code API. You add those changes or stage those changes using git add dot. Then you commit those changes using git commit -m. And then finally, you push those changes to update your repository. Okay, this is what you should be doing right now. You don't need to do anything more than this. The next level 2 is understanding the GitHub collaboration workflow, where you create a branch and you make commits on the branch. You push the branch, you create a pull request for the branch to be merged into the main branch. That is reviewed by other people. You iterate, you make changes based on the comments, and then you merge that back into the main branch. The third and the most complex workflow, which will take some time to get used to, is the branch update workflow, where you have to first, whenever your branch has fallen out of date because the main branch has been updated a few times, first you go back to the main branch on your code space, get the latest change from GitHub, check out your feature branch, merge the main branch and fix any merge conflicts, and then push the feature branch to update your pull request, and you're good to go. Okay. Try to practice it, try to set up a couple of accounts, or maybe even with the same account, you can create 2 pull requests with some merge conflicts and practice it. And here are some resources you can check out to learn more. So there is the Git documentation, of course, which is the official documentation and reference that you can check out. There is the GitHub Learning Lab. So specifically dealing with merge conflicts, etc. You can check out GitHub Learning Lab. So all of this, you can see that there is this section on reviewing pull requests. There is this section on reviewing merge conflicts. So this will set things up for you in such a way that it will give you a starting point, and then you will have to do some reviews. You will have to resolve some merge conflicts. There are some tutorials on Atlassian, some tutorials on Git Kraken. You can check out these as well. Again, Git is that kind of thing that you can keep exploring more and more. You don't have to become an expert on Git right away. If you can just do the first version, you are good to go. If you can do the second, that's great. Over time, as you start working in a team, you will be able to start working on the third version or the third workflow as well. Okay. There's a Git cheat sheet by GitLab. You can go check out this cheat sheet. It contains some of these common workflows so that you don't have to think about all the different Git commands together. And you should also check out the documentation for VS Code. So if you just search VS Code version control, you will find that there is this detailed set of videos and tutorials on how you can perform every Git related action directly within VS Code without ever having to type a single command. So most of the time you'll just be using this at work. So check this out as well. There is this nice YouTube tutorial that you can check out for local Git development. We did not cover local Git development because we are going to be using Codespaces for the rest of this course and for the rest of this program as well. But if you want to do some local development on Git, then we have some instructions on installing Git on your computer, and then you can check out this tutorial for things like git config, git init, git clone, etc. Of course, you should check out the documentation for Vercel if you have more questions about how Vercel works. But the flow we've shown here, which is connected to your GitHub account, pull in a GitHub repository code, select the root folder and just hit deploy. And then automatically, anytime the main branch is updated, it's going to create a new deployment. And anytime you create a pull request, it's going to create preview deployments that can be used for testing without affecting the main deployment. And then anytime the pull request gets merged, the main deployment gets updated automatically. So it makes things really seamless. And it is used in production. It is what we're going to be using extensively in this program. And you can learn more about their Vercel and GitHub integration here as well.